The abyssal zone runs from about 3,000 to 6,000 meters, and that's most of the ocean bed. And then where the tectonic plates come together, they're pushed down into these subduction zones, and you get sort of extra deep ocean, and that can go down to 10,000 meters.
So you probably couldn't have chosen anywhere more difficult to study fish.
No, both sort of locations. Most of these areas are in the Pacific, but also in the technical challenges of getting equipment down that deep. We use many autonomous vehicles, so we release vehicles from the surface which free fall down to site, and again, because of the incredible depth, that can be 6-7 hours just free falling. Once they land on the bottom, they'll perform a pre-programmed task. Usually we use some bait to gather animals in front of a camera and see what's down there, and then when we decide it's time to come back up, we send a coded burst of sound from the vessel. The equipment drops some ballast, and the whole thing floats back up to the surface, and we can recover it. So no huge winches, no lowering anything down. It's a bit high risk, it's a bit CTV pants stuff, but it allows us to go to some of the deepest places on Earth.
And because of that, you're finding things that nobody's ever seen before.
Just before Christmas, we went to the Mariana Trench, so famously the world's deepest spot, with the Schmidt Ocean Institute as part of the Hades program. And we did the first sort of systematic study of the trench, working from shallower to deeper and seeing these transitions in these animals. And when we got to some of the deeper sites at around 6,000 to 7,000, 8,000 meters, we found 2 new species of deep-sea snailfish. These are a group of fish, the leparids, the snailfish. Something about them makes them incredibly good at colonizing the deep sea, something sort of on a chemical level. They've gone beyond any other fish, so they've got the whole place to themselves, and they're thriving down there. They're sort of gelatinous, they're transparent, the skin is very fine, almost paper-like, and you can see the internal organs. As grim as all that sounds, they're also quite cute. They're got sort of pudgy little faces, and they sort of snuffle around and snuffle up amphipods, and that's their main diet down there. So they're going against the mold when you think deep sea fish, because I think they're quite adorable. They're quite cute little fish.
But of course, if you're catching these and then bringing them back to the surface, you've got the tremendous pressure and I guess temperature differences as well. By the time they get up, their condition is not as good as it was when they were down there. So how does that impact on you trying to study them?
I'm a big fan of our in situ work, so I think the best way to sort of see the animal is in its natural environment in situ. But of course, these incredible forces that we're putting them under when we do have to retrieve a sample, and the fragility of the animals as well, means that they're just sort of obliterated. We have to work very, very quickly in order to preserve our samples. So the gel that make up the body starts to melt, gases come out of suspension, they're incredibly fragile, so even if you're very, very careful, just handling them does damage. So we try to work quickly, often in a cold room, to try and keep the gel semi-solid. But it's a bit grim, because I really like these animals, so it's a shame to have to take physical samples. But it's also really humbling to hold this animal and see it sort of disappearing in front of you, and realize that, I can never live where it lives, and it can't even exist where I am. It's sort of disappearing, fizzing away in front of my eyes, and it makes me realize how remote these places are and how lucky I am to have seen these animals.